We are live. All right, I'll say it again. Are there any questions, any problems? And I'll mark, we got people online too, so their voices come out of the ceiling. Yeah.
Have to do both the tray. I saw there was two posted.
Yeah, whatever I've got up there. Anything that starts with an HW, you need to do. So, any questions? None at all? All right. Then we will just do problems. Let me do, I think maybe the best thing, I don't know. It's hard to say. You notice we usually do two, maybe more sections a class. But for this one, these two sections, I've decided to do just one section per class just because it's so important. I don't know where you're all gonna go, but I'll tell you that I had a student years ago who came to Tri-C and started in this course. And the last math she took at Tri-C was Calculus 3. What does happen? Some people start here and they learn from maths. I don't know where you're going after this, is all I'm saying. But whatever math you do after this, I can guarantee you're gonna be solving equations. So the better you get at it early on, obviously the best. All right, so we did 3-1, so I'll grab some of the ones. Probably what makes these harder is that they'll have fractions and decimals and all that kind of stuff in them. But that just makes it more complicated. So let me go ahead and start my OneNote. Get that up near, hey. Where's my OneNote? Solving equations. Well, the last time we finished with ones that look something like this. This is, we get hard ones into this, but all of them eventually came down to an equation like this before we finished everything off. You remember what you had to do to finish this up? What do we have to do next? Right, so you attack, normally with the rules of order, the order of operations, if you do that number, you would do 5 times it first, then you would subtract 18. But solving the equation is going in reverse and reversing your steps. So we undo everything in reverse. So this gives me 5x on the left-hand side. And on the right, I think that's 55. And then we divide by 5. And x is equal to 11. All right. Notice the structure here. I don't know if we did last time. I don't think we did. One I'm going to do next time. I don't think we did last time. Notice that x appears on the left-hand side or it appears on the right-hand side. Or the ones where x is appearing on both sides. What do you do about that? The goal in anything, since you know how to solve an equation like this easily, the goal of all of our problems will be to get it to this, and then you can just solve it. So, 'cause I'm gonna start grabbing some stuff out of the book. Now, I haven't told you what to do or anything like this, so we'll be interested in what your plans are. If you attempt to make this look like the problem we just did before it, what would you do? Like, what would you combine? Well, they're on opposite sides of the equal, so you can't combine them. Look, what we want to do is get, like the previous problem that I did, we want to get the letter on one side, the unknown quantity on one side. And that can be accomplished in this case by subtraction. For example, if I take and subtract 3b, let me see what I have next. I have 6b minus 22 is 14. Now that I did that one step, do you know how to solve it now? You should have ended up with b equals 6. Here what would be the next step from here? So now you're trying to get the letter by itself. The reason I went and put it on this side is because when I subtracted 3b, I ended up with a positive number here. And that seems desirable to me. So I have 36 on the left, I have 6b on the right. Now what? Say again? Divide by 6? We end up with 6 equals.
So you always divide by.
No, it depends on what's attached to it. Like if I had, sometimes you'll see like x over. So whatever's attached to, you just want to undo it. So if we had 6b, 6 times e, right? Which is the opposite of multiplication. But you know,
Yes, so like. Yep. You're.
maybe we'll get to some of those. And then maybe it'll seems hard. That math is, it can fool people like that. That's why, I had a student one time, I don't know, years ago. He basically flat out told me that my job was to fail. Now, a lot of people just have this inherent distrust of math professors. I don't know. They think so. What we're trying to do is show you all the things that you could run into. But anyways, let's take a look at another one of these. This is similar to the last one. Now, one of the things I said about solving equations was that you should treat the equal sign like it's a wall or something, a barrier. Can't combine terms. When you solve equations, here is my recommendation. The very first thing you should do is completely simplify each side of the equation first. Simplify these combined like terms and all that jazz. After you simplify, it should look like this. Did you get this? Just combine like terms on each side of things. Same as I get one in, so there's a one in there. So now this problem is like the one we just did before this. What would you do now to try to get it to be like the simpler version? Right now I see letters on both sides. That is not what I want. You can pick a side that I want my letters to appear on. Subtract on the right side. Okay, I would have added 2 to avoid the minus, but no big deal. I'll do what you're doing. I'll subtract it on. Subtract it out. Notice where I put them too, so I know where to combine them. So I have negative 3m plus 6 equals 3. Subtract 6 from both sides. So now it's in the format everybody's good with, right? They all get down to this eventually. So you're going to subtract 6. Subtract 6, and I end up with negative 3m. Negative. Finish it off. You do. 500. You'd be surprised how many times students tell me to add 3 on this one. Because they forget this. That's negative 3 times m. So I'm going to divide by negative 3. Divide by negative 3 on this is m equals 1. Any questions? All right, so all we're going to do, like I said, I don't know how to say this, but every single problem I'm going to give you today comes down to this eventually. They just look horrible at the outset. And we haven't shown you all the complications that occur. This one adds another wrinkle to things. Here we have 10 plus 2 times c minus 9 equals 3 times c plus 1. Your first step should have been to make the parentheses disappear. You see where I'm getting 2z minus 18? You guys should play poker because you're not giving me anything.
Like trying to see.
Do you know where 2z minus 18 came from? You can say no, you're allowed to. Say, no, it did not, I do not know where that came from, and I will show you.
I did the like terms, like it's not only supposed to be.
You can't, but inside parentheses, change everything.
Yeah.
You've got to do this and this.
2, 10.
Can't, because that's multiplication. If you take 10 plus 2, aren't you adding before multiplication? So the first thing in these things, you need to make these parentheses go away. Remember this, the first thing you're doing is simplifying each side of these things. So if I gave you this problem on the left and I said simplify it, the first thing you would do is multiply that out, isn't it? And the same thing over here, you would multiply this out, distribute. That's the very first step. Now, what would step 2 be? What would be my next move? Well, all right, am I done simplifying each side? Is the left side of the equals simplified all the way? So I gotta do that. How do I simplify the left side? So I can combine 10 and negative 18. So it doesn't matter how you write it. You could write it as negative 8 plus 2z, or you could have written it as 2z minus 8, the same deal. What about over here? What is this gonna look like when I'm finished with it? Three z minus 3. Let me pause there. You guys understand what I've done? Step. Okay, so the first thing is simplifying each side. Each side right now is completely simplified. I can't do anything more as far as simplification is concerned. Well, we do have z's on both sides. So remember, at this time, you need to choose the side that you want your z to appear on. Do you have a side that you would like z to appear on? This choice is yours. I wouldn't do it on the left side. You know why? I'll tell you why. Left is fine, you can do it, and I expect you will. I would have subtracted 2z from both sides. I'll tell you why in just a second. Think about this. If I subtract 2z, what's going to be left over here? Just z, isn't it? That means, well, after I add the 3, I don't even have to divide by anything, do I? If you had a negative over there, you'd have to divide it by -1 in the end. So you can save yourself little efforts if you, along the way, you just keep apprised of what's coming next. We're almost finished here. What should we do to finish this off? Add 3 of both sides. So you -5 is equal to 0. Are there any questions there? All right, we're gonna do more. The whole class is gonna be nothing but stuff like this. So, and there's plenty. If you need practice too, you can go online and do these till your heart is content. Plus 6. Plus 5. Minus 3. 1 plus 4 times u plus 5. All right, so let's reiterate. What's step number 1 in these problems? Simplify each side. Do that first. Simplify them all the way. Part of simplifying means making those parentheses disappear. For step 1, that's what it should look like. So the only thing I did in step 1 was scrutiny. When you combine the like terms, what are you going to get? Look on the left. How much u are you going to have when you combine them? This thing and this thing. Put them together. What do you get? Just a 3. 5 plus 6 plus 15. 21, that's right. Over here, I just got 4u plus 21. Pick the side that you would like u to appear on. Personally, I would pick the right side. It's just u all by itself. If I do that. Yeah.
No.
I'm combining this with this. No. You're simplifying before you ever begin doing the solving of the equation. So all this is just to get to the equation. Now we're ready to start solving. So simplify, now we solve. I would choose to subtract 3u from both sides because that would give me a single solitary u over here. You could subtract 4u from both sides and you'll still get there. Just not as quickly as I do. Okay, almost done. What next? Subtract 21. Now anticlimactic. So it's sort of a letdown when you do a long problem, and that's the answer. That's true. All right, so what are the steps? Simplify and then solve. In the solving routine, you want to choose which side you pick your letter to be on. And unfortunately, one of the problems with solving these equations is there's more than one way. That means I can't give you one, I can give you my way of, and it work for everything, I will be able to do everything, but students generally have a comfort zone. Many times it's not exactly the same. For example, I'll explain what students fight me on when it comes to equations. And one of the places is this right here. I choose to have my letter on one side here, whereas most students, I believe, would prefer to subtract the number first. They probably something like that. But we both should get the same thing. As long as we make correct logical moves every step of the way. All right, let's try to know one of these things with parentheses. We'll get them there. Look, I have two more of these. I don't, but based on my feeling of this class, though, I don't feel like you guys are carrying this up. Fractions are harder.
The fractions are terrible.
But let's see, if everybody in this classroom gets this one right, then we'll be ready to go on. How's that? Don't want to shortchange. That's what Luke Skywalker did. This should have been your first move. A lot of students have issues with the negative 7b minus 4. 7b 4. A lot of students that I know will actually tell me that they're one set in front of those parentheses and that somehow helps multiply through by a negative. Talking about this right here. Look at what it changed to. That's because they took a negative thing. I took a -1 and multiplied it through. Distributed at 7b plus 4. But that, like I said, it's common. It's a common issue. No, because 16 is not times it isn't. So students will put this little one here and somehow it helps them. It's kind of like, you ever remember when we take a whole number, we put one underneath of it so it makes it compatible with fractions? It's kind of like that. Anyways, after that stuff, the left-hand side is simplified as far as it can go. All I have is two terms and they are not like. So that's as far as you're gonna go with that. What do I get on the right-hand side if I simplify it? 20 plus 4d. So 16 plus 4 gives you the 20. Negative 7d plus 11d is 4d. Right, at this stage, I like to get the letter on one side, but at this, like I told you, students many times like to subtract a number here. I don't care. We should end up with the same answer. So anybody want to volunteer what they would do next? Subtract 40. So you're going to move the letters to one side. I personally, I like that because the sooner you get this objective done, the easier it seems to be. That leaves just a 20 on the right, and on the left, I have 8d plus 10. And then once again, this is the golden kind of equation. This is the thing you're always striving for. Now it's a cakewalk from here on out. Subtract 10, subtract 10. Finish this off, you would divide by 8. Ten over 8, almost certainly you'll be asked to simplify your answer, so you might as well put 5/4. Although I think in this set of exercises that I grabbed them from, it does not say that you have to simplify your answer. That means the 10/8 would have been okay. You understand? Are we okay with parenthesis problems? Can I move on now? You guys seem excited about fractions. We can certainly do those next. They're waiting. Ready to roll? Yeah, right. All right. Here we have 1/2 C plus 7/4 equals 5/4 C minus 1. You remember last time we had a problem like this and I said you don't have to work with the fractions if you don't want to. You remember what I did to make them disappear? I can't wish them away. You remember what I did to make those fractions disappear? Multiplied by the lowest common denominator. That's guaranteed to wipe everything, all the fractions out. What is the LCD on this one? Okay, 4 will work. here, if you multiply everything by 4, look how well it cleans up the equation. I mean, this 4, everything's gonna go into the 4 because, well, that's the way, the least common denominator is a multiple. Every single denominator. These 4s finally cancel out completely. And over here, it looks like I'm left with just a 2. This is a vastly more enjoyable problem to do. Now, at this stage, what would you do next?
C's on one side,
Would you do?
subtract 2C on both
That's
sides.
what I would do. Subtract 2C. You see, you can avoid the negative in front of those just with a little bit of thought. We have 3C minus 2 is equal to 7. All right, we're almost there. Add 2 and then divide by 3. 3, that's right, add 2. I'll get 9 is 3C. And then I'll divide by 3 to finish it off. So we end up with 3 is equal to C. Sense that you want another fraction. You got that. I mean, they're waiting like Pez out of the Pez dispenser. Did you? Okay, this is so. The trick, though, I don't want to call it. You can work. You don't have to do what I did in the first step. You're allowed to work with the fractions if you want to. If you got the guts, you can do it.
Can you do that?
You want me to? Yeah, I can redo this one, but with leave the fractions in.
Yeah.
I could do that. I don't like to do this because they're. No, it's not, I don't want to say confusing, it's cumbersome. Fractions are cumbersome even for people that have been doing them. I would just like do them. But if I was forced to work with them, so we're gonna redo the last example. We have 1/2 C plus 7/4 equals 5/4 C minus 1/2. So while I'm not recommending that you travel pursue this, the reason why I was slightly add here was here. This is no different than the previous problems we did. I have a C term and then a number on both sides. Right now, I can choose the side that I would like my C to appear on. I personally would pick, I would get rid of this 1/2 C. Now, the problem with this method is there's a whole bunch of stuff that you have to do in every single step, like this here. Don't I have to get a common denominator to do anything with that? What is 1/2? I mean, I've got to do 5/4 minus 1/2. That's, I can't do that. I've got to do 5/4 minus 1/4. I'm sorry, 2/4 is equal to 3/4. So this is 3/4 C. See what a pain this is? Yeah. Yeah, it works out. Read math, we'll see. Yeah. Yeah, you can't do that. They have to have a common denominator before you do anything. And when you're done, this thing is the same. So you can't just do that minus that. No, it don't work that way. And flipping, any flipping is done with division. Not addition and subtraction. So, all right, it's, but if, right now, then if I add 1/2, I will have C all by itself. I won't have anything else hanging around with it, so I have plus 1/2. Plus 1/2, and here we go again. Now I've got to add these two things. All right, then I've got to do 7/4 plus 1/2. That's the same as 7/4 plus 2/4, which equals 9/4. Now we're ready to finish it off to get C by itself. Now I will multiply by 4/3. Now we're doing it because, well, I don't have to call it living, but I'm doing this because I'm multiplying both sides by 4/3. Because this 4 will take that out, this 3 will take that out. What's the only thing left here? It's exactly what you want. Wipe these out, wipe these out. 3 goes into 9 how many times? 3. And there it is. So you tell me which way is the more preferable way.
The first one.
Exactly. We got the right answer though. All right, let's go ahead and take 10 minutes there, come back up, 2, 3 after.
I'm good. Glad they showed up then.
That's what this is. Oh, yeah, yeah. Here, differential equations. Your first exam is in week 5, not 6. Well, it's on this, in the syllabus is in Blackboard. Well, we take attendance, but no, we don't, you don't get any points for it. The only thing that can happen is if you don't show up, they kick you out of the class. Say again, I'm sorry. Oh, yeah, yeah, of course, you know, if you don't show up. But we'll only have tests in here and we'll have them in class. That's correct. Right, right, right. I'm sorry, I didn't quite hear you. What did you say? The vastness? Oh, oh, oh. Well, I know how many people are there and I know how many people are there. I also had to know the roster. I have more info than you do. But usually, it's usually about, I think I saw about 8 people online. I think there's only about 15 in the whole class, so it's. Mm-mm. All of our classes since the COVID have been smaller. Did you guys decide to wipe out the fractions? What did you use? 8. So LCD was 8. That would work. No. So the LCD is, what I do is LCD equals 8. And then what I'll do is I'll just do like 8 times this first thing. Say 8/1 times the second thing. So see here, I can wipe away these 8s. By the way, does anybody think they got the answer? Once I get going, I can't stop myself, so I'll stop this. Just make sure that you got the line. Yeah, let me break this next line out, and then I'll do that. Then I'll stop. It's hard to just sit there and do nothing though. You guys should have gotten that on your first step. After you multiply by 8, it should look like that. This is a long one. Anybody get it yet? What did you get? No. Mathematically, numerically, it's not far off, but I have a feeling, I don't know what you did. I usually come and peer over my students' shoulders, but with COVID, I can't come within 6 feet of you? What did if you want, you can go up to the board and write what you did if you'd like. You don't want to show everybody what you did? Did you multiply by 8 first? Yes, did you? So 8 was the LCD. Everybody understands that? Multiply by 8, all the and if you do that right, all the fractions should be gone after you multiply. So did you multiply by 8? All right, so arrive at where I got the 5 times 2W plus 3? Like the line that I have last on that board right now, did you get that? All right, what would you do next? Right, so distribute, right, so distribute, exactly. Distribute that through, so you get 10W plus 15 plus 10W, okay?
6.
Now what?
So now it's gonna go away to 10 W.
You gotta combine them first.
You guys, so it's 20 W. Take it over.
Simplify it all the way first, and then start moving stuff around. Now I'm at the stage where I can choose a side.
So you take them out.
So you can subtract 20W or subtract 24W, it's your call. Subtract over. You can do either one. Neither one's more right than the other one. Both correct things to do. W plus 6 on the right. And over here on the left, we have a 15. 6. So you get 9 equals 4W. We're almost done. That's what I said. Actually, you weren't far off. 2.25. Well, I wouldn't bother with decimals because they can fool you. Just leave it as 9/4. It will be correct in this case. Let me show you. I was on, well, I don't just teach classes. I have to do some things like be on committees and all this other stuff that I don't want. To be on committees for choosing who we work here and discussing a problem that had he said he would do the following. Stuff like this, 1/3 was all over the place. He goes, I would change that to a 0. Realize they're not the same thing? They are not. You know what 1/3 equals? So really, nobody wants to work with that thing in their equations. But the fact is, if you stop it anywhere, your answer is wrong. Understand? So it's not exactly right if you don't. So what I'm saying is that there's danger in using decimals. If you get an answer, if you don't know to put that on there, you'll be wrong. So if I had a recommendation, I would say don't bother with it. Don't. There's no big problems when we have decimals would be a reasonable answer, but really, I wouldn't change something to a decimal that didn't start out that way.
But it's so automatic.
It's always, no, it's, yeah. And then there's even more complicated repetitions that are more like, consider a decimal like this. I'm trying to remember which one. Oh, yeah. You could do this one, I think 9/11. Is that what it is? Maybe it's 10/11. I don't know what it is, but I think this is 0.909. So now, this is doing 2 digits. So it's even worse. If you imagine somebody putting a 0.9, they don't even recognize that it repeats at all. So yeah, there's a lot of problems with fractions. So I would say this: if it didn't start out as a decimal, I wouldn't change it to it. Are we good on fractions, or do we want another one? Actually, I don't know. How are you on fractions? You guys doing all right?
Stuff.
You have, I mean, what could you ask? You couldn't ask for a more personal educational experience than a 3-on-1. I'm begging you to tell me what, if anything, was the problem. So I go through them. If you want to get it, fine. I'm going to. If not. Homework. So we have 2/3 times 5z minus 2 minus 4/9 times 3z minus 2. 2z. Now you're a piece of advice too, even though you didn't ask. The more you write, the better you'll do. Steps that you write, things that you write, the better you'll do in this class. The better you'll do in every class. I'm just putting down after you multiply through by 9. This is what it would look like. step would have been district. As usual. Yeah.
So you.
I'll play around. You do 9/1. See this 3 down here? It's a length of it. Well, it's just simplifying. You got on that part. Like, you could do like here, you have 18/3, right? Multiply the numerators, you multiply the denominators. Now, how many times is 3 going to 18? From your multiplication table, it's 6. I'm not trying to fool you, it is actually 6. Do it one way or another. Yeah, these simplifyings are the things that hopefully you had before you came here. They slash these off. So you can cancel up here and down here. What's left of that? But if you had, right, is that cancel? This is the same thing. This 3 went into there. 3 times 2 gave me 6. After that, though, are you guys where I'm at? You guys have at least what I have on the last step? All right, we're ready to finish it off. I personally would subtract 6z because I would prefer my z to appear on the left this time. So that gives me a 12z minus 4. That's equal to 3. Oh, actually, I haven't answered your question. You said, how would you know to simplify? Because you know when you multiply by this thing, fractions have to disappear, don't they? So you know if you're getting something like over 27, you know you're getting something wrong because that thing's supposed to clear them out. All right, what do we do now? Just add 4 to both sides. So I'll have 12z 7, and then to finish it off, I will divide by 12. So another thing probably that's annoying about this part is that these answers have no sense of, they you have no idea if it feels like you got it right or wrong. That's not like 0 or 1 or something, like a great answer, but fractions of doing this is the kind of stuff that can happen. But I have to move on. Should we do, some one? One decimal. So if they got decimals, I would work in decimals. I wouldn't change it to fractions work. They give me is the route I would work in. All right, let's try one of these things. Let's do 0.3 x minus 2 plus 1. 0.25. When you think you got it, let me know. I'll come around and secretly show you the answer. Of course, the WebEx people can't do that. Come around. There's always a chance I can be wrong. I mean, that happened. I can mistakes a lot. Well, if it's 30.7.0, then yeah. So, okay.
Mine's a negative decimal.
Oh, all right, well, let's see what happens. First of all, there are, by the way, if you wanted to not deal with decimals, which I don't see them as a problem, but obviously I might need to read them. You can wipe out decimals just like you do fractions. You can multiply both sides of this equation by 100. You multiply a number by 100, where's it do the decimal place? It moves in two places to the. So if you multiply by 100, this would become 30. That would become 25. That would become. But you wipe out all the decimal stuff. If you want to go there, you can do it. It's not hard at all. In fact, every decimal is just a fraction. For us, like 0.25, that's 25 over 100, isn't it? 0.3, isn't that 3 over 10? Technically, we have fractions, if you really want to think about it. And 100 just happens to be the least common denominator. I'm going to leave the decimals in. I don't mind them. They seem not that bad to me. You have a calculator available to you. So none of these multiplications should be too bad. That's what I got on the right side. Did you get that? Multiply the 0.25 through. Same with the other side. We get the 0.3x minus the 0.6. I'll pause there to see if we're okay. Now it's just like all the other problems. What do you want to do? Do you want the x to go on the left or the right? So what are you going to subtract 0.3? 0.3. So you're going to subtract 0.3x. If you made a mistake, I am almost certain it was a misstep. Because I bet you did not change that 3 to a 3.0, did you? Why in the world would I do that? Because 0.25 minus 0.3 is equal to negative 0.0. Take your calculator and go. Negative 0.05x. So we have negative. What's 30 minus 25? Technically, that's you're doing 0.3 minus 0.25. Don't you put a 0 here to make that happen? Borrow. So, like I said, I knew exactly where the error was going to happen. What would come next though, now that I've got this, what would you do now? There's really what big to do right now. Subtract the 2.25. Subtract 2.25. Oh yeah, where did that thing go? What a bummer. Well, I got something that you guys can't do, but I can. That 0.1, where +1, where did it go? And it has disappeared. I go, this is not the same answer I got. I can simply delete this. All right. Well, it was wrong. I forgot the +1. Thank you for reminding me of it. Let me put that in. All right, I gotta simplify them before we do the next step. All right. Now let's go with yours thing, subtract 0.3. Make it compatible over here. I'm calling it 0.30. Do you know what you just did by adding that 0? Do you know what you've done? Do you know that you've caused them now to have common denominator? Both over 100 now. Just by adding that 0 in there. So that's why decimals are so much more pleasant than fractions. See what we have here? We have negative 0.05x plus 2.25. On the other side, I get a 0.4. That number rings a bell as I was doing the problem. What's going to come next? Subtract 0.25. At each stage, if you need to, get the denominators the same. So what am I? So I'm going to put negative 2.25. So I'll call that 0.40 to make it more compatible with the subtraction. So what do we have? I have on the left, I think that's negative 1.85. And on the right, we get negative 0.05x. Almost finished. What now? That's right. Divide by what?
Which one do you divide? X?
No. X. Leave it X be.
So 1.9.
X is going to stay right here. You're going to divide by that. Remember, this is negative 0.05 times X. So you're going to divide by that number to undo the multiplication. Do it to both sides. Those negatives on the left-hand side cancel out. And you get 37.
Something like 2.85 divided by -0.
How did you get negative 2.8?
I don't know.
Well, just look, don't stress so much. Take 0.4, get your calculator, and do 0.4 minus 2.25. Let your calculator, let your calculator help you out with these things. That's what it's there for, right? So that's the whole point. If you took the class before this, we didn't allow them to use calculators because we still wanted them to. Much as you want. Point of them is because these calculations are very tedious. We need a break from doing. All right, I'm going to tell you, I only have 10, so let me grab some different style of problem. I just want to make sure that I cover all the types of problems that you have. Here we've got negative 21 10, 22 equals 3 times 4 minus 7n plus 10. What's the first thing you're going to do? Can you tell me? Distribute, exactly. Step. We have 10 to 12. I want to pause right there for a second. Well, when I get 22 minus 21, same thing on the side of the equation. What do you think this means? So, no. Here we go. Watch what happens. So first thing I would usually do is try to get the ends on one side, right? So what are you going to do? I'm going to add 21n to both sides. You have to remember that mathematics at its very base is a system of logic. Look at what I have up there. Is that a true sentence? Since the n's dropped out, it's true for any value of n possible. You understand? No matter what the letter n is, this equation will work because we just simply erased them. This is what you're right. N equals all numbers. You can literally take any number you want in the original equation and put any number you want for n, and this equation will equal out. Well, it turns out they weren't even needed. What would be the opposite of that? What would be, so we have a solution. Here's all real numbers. There's one more. This is called something of a degenerate case because the n's disappeared. There's another degenerate case like that. Do you know what it would be? Could in another type of problem. So this problem is finished. in the homework, you're going to encounter a problem when you end up with something, let's say, that looks like this when you're all said and done. So the x's or whatever, the variable, the unknown quantity disappeared, and you ended up with this statement. Is that statement true? It's a false statement. What that means is that the equation was false. If the equation is false, what does that mean? Solution. So you have those two degenerate cases. You'll know the no solutions when you see it, because you'll get something stupid at the end like this. A non sequitur.
Check a few of my answers, I had a couple that came.
So it can happen. It's just there's no way that I can move around or plug in. You could try that equation. Well, I don't have an equation, but I'm just saying you'll encounter something. And when you get down and go to do the problem, you'll get to some weird equation like that, and you know there's no solution. Assuming you did everything right getting there, there's no solution. Now, one last thing, we were preparing you. I don't know if you looked at the syllabus, but do you know what the next week is? It's word problem week. Everybody loves word problems. I know. It's a long time. Excitement to get those things. But we put, besides not to get you with them all at once, we decided, we got excited. They're going to start giving you sentences to try to get you to build up to it. So these are thrown in just like a secondary fact, it seems, because they're in preparation for what comes next. But you'll see something like this. Let me break down one of these things. Yeah. It may be, but I'm not there yet. I'll get there, I'm sure. I don't know if you have to solve them. Let me see what it says. Write each statement as an equation and then, right, so we'll see if you're right. So they want you to first change this. This is the hard part of word problems. It's taking what you're given and turning it into an equation. You agree with that? That's always what people complain about. The equations don't seem that bad once you do it. What I do in these things is I will locate the verb. Where is the verb in this thing? They would ask that kind of question in the math class, didn't you? We're not going to go far. We're not going to be conjugating stuff. Or anything. We're not going any farther than that. Where's the verb in this sentence? So when was the last time you went out and ordered something? Yeah, we're gonna go boring. No. It is, but no, it is not. This is the verb. The state of being is an action word. All right, so the numbers do themselves though. 12 is easy enough. Just remember, is equals, okay? It doesn't, the verb actually was, I don't even think that matters. The fact is, since it has a verb, it becomes a sentence. Equations are actually grammatically sentenced. So any numbers you see, you can just bring down. And if you luck out, you can write down things right underneath of the sentence. So can you tell me mathematically what this would be? And what would we do with this thing? Take the letter. And that's what they're looking for your answer. You understand? That's part of, well, that's step one. Step two is to solve it. So to solve it, what would you do? Subtract 15 from both sides and you get, I think she said it, -3, right? So as the two parts, you need the equation and the answer. Yeah.
I'm getting out of the textbook, but they are, yeah, they're the same ones. Usually when you ask questions from the homework, I'll grab them from the homework and copy and paste them into this thing and we'll solve them. So you're gonna have some preparation for this. What are some act, I don't want to say action words, the action word is statively are, is believe it or not, action word. You're being, doing something by being. But, more than, what are some words that would come up mathematically? So, the word subtraction, but probably not subtraction. No, addition, obviously, but those, if you use those words normally, like you say 25 subtract 7. Let's say you say 27 minus 5. Minus, right? That's so minus. What are some words for addition? We have more than, total of, sum. Or some other one. Subtraction has, I said, minus, less than. So if I have, what is 22 less 7? Say 22 less 7. 22 less 7. 7 less than 22. How's that? What is that number? 7 less than 22. Right. But mathematically, though, less than means that I take this number, subtract this number from. So there are things that they don't always go directly in order when you're making these. But I advise you write out the sentence, find the is, put your equals on it. Then you have a left and a right side immediately. The rest of the stuff I can copy as needed. Okay. Good luck, and well, obviously, nobody has questions, so I don't know if you guys are really doing it. I haven't checked the homework results yet. So I have no idea how well you're doing. But based on your silence, I am guessing you're going to get 100% of it. What's that? Oh, excellent. It's not for the practice. That's all I got today anyway, so I'll go ahead and cancel out of my thing. Is everybody, you guys get it? I'm going to close out my WebEx. Stop sharing. Stop recording.